Hey everyone, in this video we'll be going over some SAT non-calculator problems. So problem number 1 is 2x minus 1 times x plus 2 squared is equal to 0. What is the solution set to the equation above? So in this problem we're simply trying to find the zeros or the roots of the equation. So what we'll do is we'll take our two factors here. So let's take our two factors and we'll set them both equal to 0. So first we have 2x minus 1 is equal to 0, and then x plus 2 is equal to 0. And for now, remember, ignore the squared because when you're solving for roots, you wouldn't repeat the same solution. And x plus 2 squared would have the same solution twice, so you only need to equate it to 0 once. So now we solve for x. So first we have 2x is equal to 1. So x is equal to 1 over 2. And next we just subtract both sides by 2. So then we get x is equal to negative 2. So that means our solutions would be 1/2 comma negative 2. And that matches with answer choice A. So now on to the next problem. So here we have 3x plus 4i minus 2 plus 3i. In the complex number system, which of the following is equivalent to the expression above? Note that I is equal to root of negative 1. So this is quite simple because there's no multiplication or division or anything. This is just straight up subtraction. Because when we have here, we know that we're just subtracting these two separate, factors. But one tricky part that a lot of students miss is that this subtraction symbol has to be distributed throughout the function here. So it has to go onto the 2 and the 3i. So your new equation will become 3 plus 4i plus negative 2 minus 3i. So we'll just get rid of this plus here. So just minus 2 minus 3i. And then that would equate to, we add like terms, so we can add these two, and then we add these two. So then we get 3 minus 2 plus 4i minus 3i. And then we get 1 plus I. And 1 plus I is our final answer, so it's B. Now for this next problem, we have x minus 1 over 3 is equal to x plus 1 over 2. So here our first step would be, knowing that this is a sort of proportion, we know that to solve for x, we can cross multiply. And that's a big key point to make this problem a lot easier. You could multiply by 2 and then go from there, but just knowing that you could cross multiply makes the problem much easier. So now we have 2 times x minus 1 is equal to 3 times x plus 1. And then we just distribute this how we would normally distribute it. So we would have 2x, so we have here and then here. 2x minus 2 is equal to, and we distribute the 3, 3x plus 3. So then we get minus 2x, and then also minus 3, and then our final solution is x, because 3x minus 2x is x, is equal to negative 2 minus 3 is minus 5. So this is our final answer, so it's answer choice A. Now for the final problem, we have p of x is equal to x squared minus 11x plus k. In the function above, k is a constant. If 2 is a 0 of the function, what is the value of k? Now to start, we're given one of the zeros, which is super important. Because since we're given one of the zeros, we're able to find the other factor, or the other 0, because we have this middle value. So let's just write this out. So we have the x minus 2 as one of the factors, because since 2 is the solution, we know that it has to be x minus 2, because x minus 2 as a factor results in x being equal to 2, or like the 0 being 2. So you have to take the opposite. So one of ours is x minus 2, but then from this x minus 2, how do we get negative 11? the only way to get negative 11 is to have x minus 9. Because if you were to have a positive number here, it could become positive 11. But the only way to get negative 11 is getting a negative 9. So now that we have our equation is equal to p of x, now we just solve normally. We would get x squared minus 9x minus 2x plus 18. And just to verify, we have is equal to p of x. So we have x squared minus 11x plus 18 is equal to p of x. And since we're solving for k, which is its final value here, we know that 18 is our final answer.